We're now going to go ahead and create the new layout for our example. Now I've already gone to my layout folder, selected the original main.xml file and deleted it from the project, which you can do either by hitting the delete key or by right-clicking the file and selecting delete from the menu that appears. Now to create the new layout, we're going to be adding a new file to this layout folder. I just want to point out in welcome.java that we're currently getting a compilation error here on line 11 of the original source code file, and that's because the main.xml file that was originally being referenced by the welcome class no longer exists. So it is actually important that we name the new layout file main.xml, because in Android the name of that file becomes a so-called resource that we can access in our source code to say which layout to load when the app starts executing. So in order to fix this compilation error, I need to either create another file named main.xml, or if I name that file differently, I have to update line 11 in this source code. And we'll talk more about the resources that get auto-generated for you in the source code when we move on to the next lesson. So let me go ahead and close that file. Going back to the layout node here, we're going to right-click and select New, Other. And we now get the new dialog, and within our Android node, we have this Android XML file option. When you click Next, you're presented with the new Android XML file configuration dialog. Now, again, you have to specify the name of that file, so I'm going to call it main.xml. It is going to represent a layout, so that radio button was already selected by default here. It's being placed into the res layout folder, which, as you recall, is where I right-clicked and then selected New, Other from. If it was not getting placed there, you could explicitly modify this folder and make sure it gets placed properly into the layout folder. And then finally, we have the linear layout as the default layout for this new XML file, but we want it to be a relative layout, so we're just going to select that and click Finish. And now it opens the new main.xml file in the visual layout editor. Notice, by the way, that it went back to all the default configuration for the visual layout editor. So once again, I'm going to select Android 2.3.3, and I'm going to select the WVGA resolution. And now we're ready to start working on the actual XML description, if you will, of our graphical user interface. Now, for this example, we want to use a couple of images in the example. We want the Android logo to appear, as well as my Dytel logo, the bug logo. And in order to use those resources in our app, we have to bring them into the app. And the easiest way to do that is just to drag them from an Explorer window on your platform into the project. So you'll notice with the examples that we've provided an images folder. Here are the two images that we're using in the example. So if I simply drag those, and I'm going to drag them in this example onto the drawable-hdpi folder. Now you'll notice, and I'm going to copy the files, by the way, you'll notice that in that folder or in the folder's name rather, it says -hdpi, as well as we have two other drawable folders with -ldpi and -mdpi in the names respectively. Now these folder names represent images for different devices that have different pixel densities. HDPI stands for high density, and such a device has approximately 240 pixels per inch on the screen. An MDPI device has approximately 160 dots per inch on the screen, and an LDPI device has approximately 120 dots per inch on the screen. In addition, you can actually create other drawable folders with extensions on them like XHDPI for extra high density, which is approximately 320 pixels per inch on the screen, or dots per inch rather. And then there's a -no DPI folder that you can have for any kind of image or resource that should not be scaled by Android. Now, the relevance of all these different drawable folders is that it helps you optimize the visual resources that you're using in your apps for different size and pixel density devices so that your images and videos can appear and look the best possible on each individual device's screen. Now, they've done a really good job of documenting how all of this works in the developer documentation for Android. There's the supporting multiple screens documentation page, which you can find here at developer.android.com/guides/practices/screens_support.html. I highly recommend that you take some time to read this supporting multiple screens documentation in detail because there's a number of key things that are talked about on this page. One is this issue of the different dots per inch for different devices, but also the fact that you might want to have different layouts for different size devices and different screen orientations as well. And we'll talk about various issues with respect to different screen sizes, different screen resolutions, and different orientations as we proceed through all of the different apps that we've designed for this Live Lessons video product and for our corresponding book, Android for Programmers. Now, in this example, we are focusing on designing for a smartphone device that has 800 by 480 pixel resolution, and its dots per inch is approximately 240 dots per inch, which is why I placed my images into the drawable-hdpi folder. Now, if I take this same app and I run it on another device that has either low DPI or medium DPI, it will still be able to take the images that I've only placed in the HDPI version of the drawable folder and scale them accordingly for those other devices with different screen sizes and different pixel densities. The problem is when you're dealing with bitmap type images, they don't always scale very nicely. So if you really want these images to work well on all sorts of different devices at different pixel densities, one of the things you'll want your art folks to do, or you if you're the artist, is to create your images at different sizes for the different pixel density screens and then put them into the appropriate drawable folders, and the Android operating system will automatically choose the appropriate set of images based on your device's size and pixel density as well. So we've now incorporated the android.png and the bug.png images into our drawable-hdpi folder, and at this point we are ready to really go ahead and build the graphical user interface. So now what we want to do is start placing items into the layout. And actually the first thing we're going to do is modify our relative layout a little bit here. For one, we would like to change the name of the relative layout. As you'll see when you start working with code in the next lesson, you're often going to want to interact with specific components on the screen, and the only way you can interact with them is if you have a variable name that represents those components on the screen. So one of the things you'll often want to do is to specify a new ID for your component. Now I'm going to scroll down into the relative layouts set of properties here to the ID property, and right now it doesn't actually have an ID property specified. What I'm going to do is type @+ID/ and then give it a name, and I like to name all of my components with their class name in them so I know what type of component they are. So in this case I'll call it the welcome relative layout. And when I press enter, let me just go show you what that did in the XML file here. By the way, within Eclipse, if you want to resize a particular window temporarily, you can double click its tab and it will occupy the entire IDE area. If you double click it again, it'll go back to its original size. Now the reason I did that is I wanted to show you this new Android ID attribute that was added to the XML. Now the significance of the plus sign here is that it means we're creating the name welcome relative layout for this relative layout object, if you will, and the syntax for referring to a given element within the XML description of the GUI is @ ID / and the name of the component. If the @ is followed by a plus, that means we're creating the name. If the @ is not followed by a plus and then the word ID, it means we're just using the name of an existing component. And we'll see both of those cases in this example. So let me go back over to my graphical layout. So notice, by the way, in the outline, it now says the actual variable name of my relative layout that we configured. Now, the next thing we wanted to do is change the relative layout's background from black to white. And to do that, we can use the background property of the relative layout. Here you see background. And you'll notice that I can type directly in the value field, or I have the option of clicking this ellipsis button, which will allow me to select a resource that represents the background. Now, in this example, we're just going to hard code a color, and in Android we use the RGB color scheme, and in the RGB color scheme, if I want the background to be white, I can just type 6Fs, which stands for the red, green, and blue portions of this color. So the first 2 digits in hexadecimal format represent the red, the next 2 digits represent the green, and the last 2 digits represent the blue. In addition, you can also use an 8-digit format, which is the alpha red, green, blue, and that alpha part allows you to set the transparency of the color. And finally, if each pair of digits is the same, we can shorthand this with just single digits. So 6Fs is actually the same thing as 3Fs as far as Android is concerned. So if you just provide a 3-digit hex number, it automatically is going to take each of those digits and duplicate it to represent the red, green, and blue portions of the color. So I'm just going to explicitly use the 6Fs in this case, and you saw already that it changed the background of the design area to all white. Now, the next thing we want to do is put our text view into the user interface, and we can do that by just dragging it and dropping it onto the relative layout. And by default, you see it appears here in the upper left corner of the relative layout, and it also has built into it the text that it's going to display, which is currently just text view, so that you can see it in the design area. Now, there's something very important that you need to know about string contents in general within an Android application. All of your strings, by convention and by good programming practice, should be separated out of your application and placed into string.xml files that represent the strings for different languages, so that you can easily internationalize or localize your app for different languages. So you'll notice here in the values folder, there's already a file called strings.xml, and if I open that, you'll notice it already has 2 of what we call string resources in it, one called hello and one called app_name. If I select either one, you'll see that over here it displays both the name of the resource and the value of the resource. So you may remember when we first created this welcome app, it was displaying Hello World Welcome on the screen, and it was using this hello resource to help me do that. In my example, what I want to do is to now specify the text of that text view, and in order to do that, I'm first going to create a new string resource that is going to represent the text that I would like to display on the screen. And if I then wanted to internationalize this app to display it in different languages, what I can do is have many different strings.xml files where the base name strings will be augmented with a language encoding that represents what language strings are in that file.